Welcome to Inside the Lab with Aero Electronics, the web series dedicated to exploring the latest in technology and electronics. Today we'll look at Linear Technology's LTC2000A, a 2.7 gigasample per second current output DAC, which has exceptional spectral purity, low additive phase noise, up to 16-bit resolution, and high full-scale output current that is adjustable from 10 mA to 60 mA. The low additive phase noise of 156 dBc per hertz makes the LTC2000A suitable for use in the most demanding applications, such as broadband wired or wireless communications, radar, and instrumentation. The LTC2000A achieves 80 dBc spurious-free dynamic range, or SFDR, at 50 MHz, and SFDR better than 68 dBc from DC to 1.08 GHz to meet the stringent requirements of these applications. A 32-lane DDR LVDS interface helps drive the high sample rates, but the device can also be configured in a single-port 16-lane configuration while still providing up to 1.35 gigasamples per second. Today we have Linear Technology's DC2085 demo kit to show you some of these capabilities. On the board we have the LTC2000A-16, which is the 16-bit version and comes in a 15x9mm VGA package. There's also a Stratix FPGA, which is used to drive the 32-lane DDR LVDS interface. For timing, we have the LTC6946 ultra-low noise integer and synthesizer with integrated VCO, and that's used to generate the maximum sample clock of 2.7 GHz, and it's also the recommended timing solution for the LTC2000A. To configure that, use PLL Wizard, and we'll load the appropriate PLL settings file, and then I'm going to change the divider to 1, and you can see that we get that 2.7 GHz clock, which is the max clock the LTC2000A can accept. And then to configure the LTC2000A, you open LT-DAC-Gen and set this to 2700 MHz to match the clock that it's getting. We'll set the number of samples to its max, and we'll add a sine wave. And we'll add a sine wave at, say, 100 MHz. We'll update the FPGA, and we'll view the plots. And this view plots gives us a preview of what the output will be. So you can see a nice, clean 100 MHz signal in the spectrum, and then if we zoom in on this, we can see what it will look like in time. So you can see that nice 100 MHz sine wave. LT-DAC-Gen and the LTC2000A support multi-carrier signaling as well, and so if I add a second sine wave, and we'll put that at 500 MHz, and maybe we'll move this one up to 700 MHz, and I update my FPGA, you can see that we get this notification that there have been a lot of clipped samples. One way to fix that is to drive up the attenuation on the output. So if we go up 6 dB, and we update our FPGA, that should take care of that. If we view those plots, you can again see this nice 500 MHz signal and 700 MHz signal. Now, LT-DAC-Gen supports additional waveforms, but it also supports importing and exporting plain text files, which will allow you to do arbitrary waveform generation. Linear Technology's LTC2000A family of high-speed DACs provide the performance and feature set necessary for applications requiring high sample rates without compromising signal quality. For more information, visit aero.com.